Hello everyone. Welcome to the course on computer networks. Today's topic of discussion is switching. Myself, Mr. Ankit Khandelwal, Assistant Professor from the Department of Faculty of Computer Engineering, Purnima University. The content of this lecture are as follows. First of all, we will see about the introduction of the switching, how the switch works in the local area network, and then we will see the practical learning of the switch in the local area network using Cisco Packet Tracer. The objective of this lecture is to provide an understanding of the network switches, their working principle, and their practical application using Cisco Packet Tracer. So by the end of this session, students will have a foundation understanding of how switches operate in a network and how to simulate network setups using a packet tracer tool there. The course outcome for this particular lecture is that the student will be able to understand the role of switching in networking. That is, they will be able to explain the importance of switch in data communication and their function in network infrastructure. Second, they will be able to describe how switch works. They will learn about the MAC address table, how the switch stores the MAC address table at a particular port there, how the switching mechanisms take place, and how data packets are forwarded within a network there. They will be able to perform practical simulation using Cisco Packet Tracer. That means they will be gain hands-on experience in configuring and troubleshooting network switches using simulation software there. Now, first of all, we will see the concept of switching there. So switching is the process of forwarding data packets. So it is the process of forwarding the data packets between devices on a computer network there. And particularly here, the computer network will be local area network there. Now, switches are the networking devices that operate at the data link layer. Okay, so it operates at the data link layer of the OSI model, that is Open System Interconnection model there. A network switch is a device that connect multiple devices within a local area network. Unlike hub, okay, unlike hub, switch is more intelligent and makes forwarding decisions based on the media access control there, because switch has its own memory. Okay, the switch has its own memory. Why this memory is required? This memory is required to store the MAC address. Okay, to store the MAC address, we require this memory there. Okay, now what is the difference between hub and switch? Hub does not have a memory and switch has its own memory to store the MAC address and also that port number to which the particular MAC address is being connected there. Now let us see how the switch works. So as what we said, that switch maintains a table that is known as MAC address table, also known as forwarding table. So this table is doing what? It is doing a mapping of a particular MAC address to the corresponding switch port. So as a device send data to switch, the switch goes to its memory and see the destination MAC address in its memory, and in front of that particular MAC address the port number is being written. So after getting the packet from the source, the switch copies that particular packet to the destination port number, and then from that port number it delivers the data to the receiver there. So when a switch receives a data frame, okay, now see here, when a switch receives a data frame, it examines the destination MAC address, and using it MAC address table, the switch determines the port associated with the destination device there. Let us see the working of the switch. So now here it is a switch, and this switch is having total 30 ports. Okay, this is the switch. Now, what we are going to do, we are going to connect a sender PC and a receiver PC to this switch there. So we will use a straight through cable. Okay, straight through cable we will use, so that is copper straight through cable. So whenever there are two different nodes being connected, we use a copper straight through cable. And when the two end devices are of same type, then we use the copper crossover cable there. So see over here, we have used the straight through cable to connect the switch and the PC. And this sender PC is connected to the port number 1 of the switch. And this receiver PC is connected to the port number 19 of the switch there. Now, what we will do, after connecting these two PCs to these two ports, we will now send a packet from the source to the destination. Now, over this packet, what is there? On this packet, we are having a source MAC address, that is media access control address. Okay, and on this packet there will be also a destination MAC address. Now what will happen when this switch is going to be used first time? The packet from this particular PC will be transferred to the port number 1 of the switch. Now, what I told, that the switch is having its own memory, and in this memory, what it is going to store? It is going to store the MAC address and the port number. So how it starts to fill its memory? So when this packet will be reached to the switch at port number 1, the switch will see the source MAC address and the destination MAC address. So what it is going to do, on the basis of the received packet, it will fill the particular MAC address and the port number. So it will now just fill the source MAC address and the source port number there. So the source port number is 1, and let us say the MAC address of this sender side PC is A. We are taking just for an example. So this MAC address will be stored in this particular MAC column, and in front of this MAC address there will be the port number to which this particular PC is being connected to the switch. Now, in the first attempt, what the switch will do? Switch will send the packet to all the other ports. So let us see that I have connected this particular receiver to which we are sending the packet at port number 19. Now in this particular image, I am connecting another PCs, that is, there is one more PC over here. Okay, to this port I am using another PC. So what will happen in the first time? First time the switch will send the packet to all the PCs there. Okay, to all the PCs. Now these two PCs which I have drawn now, actually they will cancel this particular packet, because destination MAC address is of this PC there. So this PC is going to accept the packet. So this will accept and these two will deny the packets. After receiving the packet, this particular PC, that is receiver PC, will now send an acknowledgement. Okay, the PC is going to say an acknowledgement. So on the acknowledgement packet, what will be there? There will be a up. Now this receiver will become a source and this particular destination will become a receiver there. That means there will be an exchange because the reply has to be go from receiver to the sender side. So when this acknowledgement packet will reach to port number 19, then the particular switch will store the MAC address B of this PC with and map it with the port number 19 over here. In this way, the switch is going to use in future these two port numbers for its working there by seeing the memory table. Now, as I told, what is there? There is a table, and on the basis of this table, the particular switch is going to send the data. Now, suppose I am sending a packet from this particular PC. Let us suppose this packet is this is PC number A and this is PC number B. Now, when this packet is going to from A to B, this packet will be received by the switch at port number 19. When this packet will reach at port number 19, the switch will see the source MAC address and the destination MAC address. Then the switch will go to its memory and it will see the destination MAC address is it in the memory or not. If it is in the memory, then it will go to that particular MAC address and will see the port number. It will found that the port number is 1. So now what the switch will do? Switch will not send all the packets to all the other ports. It will just send this particular packet from port number 19 to port number 1. And after that, the switch will transfer this particular packet from the port number 1 to the PC B there. In this way, the switch works for in the local area network there. Now, we will see this practical working of the switch on the Cisco Packet Tracer. Now we are on the Cisco Packet Tracer. We will take a switch. I am taking switch number 2960. And now we will take 4 PCs. 4 PCs. And we will connect the PCs to the switch. Let us see. As I told you, when the two AND nodes are different, we use a copper straight through cable. So this is the copper straight through cable. I am going to use this copper straight through cable to connect all these PCs to the switch. So we are taking fast Ethernet 0 on this port, that is PC 0, and we will connect it to the switch there. Okay. Then we will connect this particular PC with the switch. Fast Ethernet 0/2 port. Then this PC2 will be connected to the Fast Ethernet 0/3. Then this PC will be connected to the Fast Ethernet port 0/4 over here. Okay. Now you will see these orange dots are being seen on the wire there, because switch takes some time to do all its functioning. So that means this is a wait sign over here. Now when the switch will configure its all the things, these orange dots will be converted into the green dots over here. Now what we are going to see, this switch is having total, that is 1 2 3 4 5 and 6, total 24 ports. Okay, you can see these, you can see these particular ports over here. These are the particular ports, these, fine, these are the particular ports. And now these are the ports. Okay, so there are total 24 fast Ethernet ports and 2 gigabit Ethernet port there. After that, now what we are going to see, that we have connected all these PCs to the switch there. As I told you that the switch works in the local area network. It works in the local area network there. So we are going to create one network, and that network will contain all those PCs. So I am taking a class C IP address 192.168.1.0 is the network address. So now this PC, let's take this PC, let me remove first of all this with the help of the eraser. Right, this is the over here eraser. Now we are making an IP address 192.168.1.1. The IP address of this PC is 192.168.1.2. This PC2 is having an IP address 192.168.1.3, and this PC is having an IP address 192.168.1.4. Okay, so we are not going to assign all these IP address to these PCs. Initially we will see that the IP address are not being assigned. So we will go on this PC, we will go on the desktop and IP configuration over here. Okay, let me erase this thing. Okay, so IP address we are going to assign over here. Now the PC is having 192.168.1.1. Subnet mask will be 255.255.255.0 because this is class C. We have assigned the IP address to the PC, this particular PC. Now we are going to assign the IP address to this PC 192.168.1.2, and the subnet mask is 255.255.255.0 over here. Then we will take PC3. This PC3 is having an IP address 192.168.1.3. Subnet mask again 255.255.255.0, as it is a default subnet mask for the class C. Then we have this IP address of this PC 192.168.1.4, and the subnet mask is 255.255.255.0 there. Okay, so we have assigned the IP addresses. Now we will see how to send the packet from one PC to another PC. So we will go in the simulation mode. We are going into the simulation mode, and we will use this PDU this PDU. Let us take the source PC is 192.168.1.1, this IP address, and we are transferring this packet through the switch to the IP address 192.168.1.4. So let us see how this switch will work over here. I'm using this forward arrow over here. See, the packet from the IP address 192.168.1.1 will first of all go to the switch. This is going to the switch there. So it is the first time. That's why the switch will transfer the packet to all the other remaining 3 PCs. Why? Because at a single time, it is going to fill its memory with the MAC address and its port number. So here, what we are having, the switch will be having a that is memory. Okay, switch will be having a memory. So, and the memory, what it is going to do, it is going to store a MAC address and port address to the PCs connected. So now when this packet is sent from this port to the switch, okay, so this 192.168.1.1 is connected to the port 1. This has been now stored in the MAC table of the switch there. Now what you will see, as I told you in the initial phase, the switch is going to send the packet to all the other 3 PCs. Let us see that. We will use this again forward arrow. You will see that these 3 packets are now sent to the PC2, and this IP address 1.2 and 1.3 has discarded because this packet was intended for the PC that with the IP address 192.168.1.4. Now this has accepted, and the remaining 2 PCs have discarded these this packets there. Now what will happen? This PC that is with the IP address 192.168.1.4 is going to send a acknowledgement, and this acknowledgement will be intended for this PC there. So what you will see now over here, that the PC will send, this PC will send, that is with IP address 1.4, acknowledgement will go first of all to the switch. Let us see there, it is going to the switch, and after it is being received on the switch will go to its table, will see the address 192.168.1.1, and this packet now will be delivered to the this PC there. Now see over here, this has been sent to this one over here. Now the next time when again this PC is going to send the packet to the IP address 192.168.1.4, now it will not be sent to all the 3 PCs, remaining 3 PCs. Now it will, because what will happen now, this switch is going to again fill the address 192.168.1.4 with the port number 4 there. So when the next time the packet will be sent from this PC 1.1 to 1.4, let us see now. This goes to over here, this packet gone over here, and this switch will now don't send the packet to all the 3 PCs. It will just send this packet to the IP address 192.168.1.4. Now see over here. This is how the switch works there. Okay. Now we will see this particular thing in comparison to the hub there. So now I'm going to make a hub. So let us choose a hub from this particular point there. So we are going to take a hub, choose a hub. We have chosen a hub over here. We will connect some PCs to the hub. We are connecting these PCs to the hub, these three PCs. Let us take one more PC, this PC. Okay, we'll connect these PCs. Again, the two end devices are of different type. So we are going to connect this with the hub fast Ethernet 0. Then this will be connected to the fast Ethernet 1. Then this third one PC will be connected to the fast Ethernet 2 port. Okay, and this will be connected to over here. This will be going to be connected to the with this one. Okay, now let us see that this packet will be sent from first of all we will assign the IP address. Sorry, we will assign the IP address over here. So we are going to assign the IP address. Sorry. Okay. Let us take the IP address over here. Right. Desktop IP address. Let us take 192.168.1.5. We have assigned it. Then we are going to assign it over here. Desktop 192.168.1.6. Assigned over here. Then we are going to assign an IP address over here. 192.168.1.7. Okay, we have assigned over here. Then we are going to assign the IP address over here. 192.168.1.8. Okay, we have assigned. Now let us see how the switch is going to be work. See over here, we are sending this packet from this PC to this PC there. Okay, so let us open the simulation. So when you will start it, just see. I'm forwarding it. This goes to the hub. Okay. Now what the hub will do? Hub will send this packet to all the remaining three. See, and it will again check the and on the envelope there will be a destination address. The two other PCs will going to be cancelled. So every time, whenever we are going to, okay, packet tracer has stopped working unexpectedly. Please, okay, okay. There is some error. Fine. Now, we have seen that what we were doing. We have compared the switch. This was the switch over here. This was the switch. We have used over switch here, and we have used a hub over here. So what we have seen in the simulation mode, that whenever we are going to use a hub does not have its memory. So how it works? It sends the packet to every node there. Okay, so it to every node. See over here, we are going to do with the help of this. Let us see now. I'm taking a packet over here. This packet is now going from this particular IP address 192.168.1.5 to 192.168.1.7. Okay. See, the packet has gone to the hub, and after that hub will transmit it to all the other three remaining PCs, but it will be only accepted by the destination PC. It will be discarded by other two PCs there. So it is not going to check its memory because hub does not have its memory. It just pass on the packet to every device which has been connected to the particular thing there. So this is how this particular thing now the reply is being going. So this reply is also going to be copied to all the ports of the hub, and it will deliver to the all the devices there. So it will be received only by the intended source there, which has sent the packet to the destination. So this is now the switch. Okay. So in this contrast, that is switch and hub, what we can say that switch is going to have a memory, but hub does not have a memory. It every time sends the packet to all the other particular PCs there. Okay. Now, this is the basic difference between the switch and hub. The switch works on the, that is layer 2. The switch works on the layer 2 there, and the hub works on the layer 1 of the OSI model there. Okay. Switch use the MAC address. Switch use the MAC address, and it has a memory. It also has a memory, but hub does not have a memory, and it not just see any address, it just pass on the packet to all the other particular PCs there, and on the packet whomsoever address has been written, that particular PC will accept that particular thing there. Okay. Now this is how you can use the switch in the local area network in comparison to the hub there. Okay. So we have seen the difference between the hub and the switch, and we have also seen the working of the switch there. Now, in this lecture, we explore the fundamental role of switch in networking, their working principle, and their practical implementation using Cisco Packet Tracer. We learn how the switches uses table MAC address table to forward data efficiently, and how they contribute to seamless network communication. Additionally, through hands-on simulation, we gain practical experience in configuring and troubleshooting network switches there. So by mastering these concepts, students are now will be able to better equipped to understand and design network infrastructure effectively. This knowledge lays the foundation for the more advanced networking topics, ensuring a strong grasp of real-world networking scenario. We have referred to the books, that is to the Cross, Tannenbaum, and the Frozen, and we have used the research papers. Thank you and have a good day.